for joining Earth Echo Expeditions, a YouTube Live at the West Basin Municipal Water District in El Segundo, California. My name is Jacqueline Durakis, and I am the Expeditions Manager for Earth Echo International. We are so excited to have classrooms from all over the globe joining us as we explore water recycling as a possible drinking water supply for the residents of Southern California. This live event is part of the launch of Earth Echo Expedition Water by Design. Water by Design is a set of videos, lesson plans, design challenges, and other tools to support students in the exploration of water scarcity, water resource management, and droughts. We're excited to share these materials with you all at no cost on our website, thanks to support from our presenting sponsor, the Northrop Grumman Foundation. You can explore these materials at our Earth Echo's website at www.earthecho.org. Before we get started today, I have a little bit of housekeeping. So we love participation from all of you watching. So how do you participate? Ask us questions. If you're watching on the YouTube website, you can use the Q&A app. If you're watching directly on Earth Echo's website, just use the Google form beneath your viewer. Please go ahead and post your questions now or at any point during our live event. We'll be answering questions during a few spots in the event and have set aside time at the end for additional Q&A. To get everyone started, we have Earth Echo's founder and president, Philippe Cousteau, calling in to welcome everyone out there in our audience. Philippe?
Sorry, guys, we're going to hold for just a second on Philippe. Jacqueline, he has not been able to call in. So this is Stacy Rafalowski, the program director, but we'll have him on shortly.
Okay, well, I'll go ahead and introduce our classroom that we have live today. So we have Mrs. Griffith's classroom from Ario Seco Museum Magnet School in Los Angeles, California. So go ahead and say hi, everybody. Thanks for joining us. Our special guest and host for today is Mr. Daryl Ramos Young, and he is coming up to us live from the West Basin Water Municipal District, and he's accompanied by his coworker, Diego Guerrero. Guys, you want to take it away?
Great, thank you, Jacqueline. Can everybody hear us okay? Put up a thumbs if you can.
Oh, can you guys hear us? Problems? Thumbs up? No one?
Can Arroyo Seco Magnet School hear us? If so, raise your thumbs.
Yeah,
Great.
perfect.
Thank you, gang. And great to see you guys. You guys live in my neck of the woods. I live right over there by Burbank Middle School. Anyway, I am the Public Information Officer for West Basin Municipal Water District. And what I do is really cool. I think I have the best job in the world. And that is talking to our chemists, our water resource planners, our accountants, our engineers, our facility operators to better understand what they do in providing water, drinking water to our service area. Diego, as my education assistant, what role do you play?
Well, hello, everyone. Nice to meet you all. Nice to have you guys here. I am Diego Guerrero. I am the education assistant for Daryl. And what my job entails is that I'm basically helping out with Daryl with anything that he needs assistance with. And that mostly includes, but not limited to, the confirmation bus trips that we have to send out for all the other field trips for the rest of the year. All of the other nuances, making sure that the field trips are actually set up and prepped. And just recently, also making sure that all our winners, as well as our education program itself, is running nice and smoothly. Whenever Daryl needs anything to be added, I'm the guy that goes and adds anything new.
So we have the really great job of taking what our agency does and communicate it to the general public, such as all of you tuned into our YouTube live session today. Live video sessions, streaming is one way that we communicate to the public. We can communicate through websites, through exhibits here at our visitor center, at our water recycling facility, through community presentations and facility tours of our water treatment plant that Diego was talking about. Our agency provides drinking water to the South Bay cities here in Los Angeles County. So there's 17 cities that are right in, well, basically the Pacific Ocean is our backyard. And so our responsibility is to provide drinking water to over 1 million people. The day in the life of a public information specialist or officer, will be like this. Okay, Diego, you want to follow me?
Yep. Here
Let's
we go.
take a little tour of our water recycling facility. So if you can follow me this way, I want to share a typical day could be in the morning, leading a tour of 60 third grade students on a tour of our water treatment facility out this doors. You can see we have lots of safety glasses that they all get suited up in, lots of hard hats that they have to put on their heads to protect them, their noggins, and then we have safety vests by the truckloads for all the groups that are going to be passing through. And for our younger students, you can see our cute little safety vests that we have small sizes for them to make sure that none of the vehicles that may be traveling out there will accidentally run on top of them. If we take a look into our water quality lab in the afternoon after a tour, I may come into the water quality lab. Come on, Diego, so the door doesn't slam on you.
All right.
And under our water quality lab, I may go ahead and talk to one of the chemists here in the lab and find out what kind of tests.
Before we do that, would you mind? We've got Philippe on the line just to welcome everybody. He is in transit. Do you mind if we just take a quick pause and let Philippe give a welcome? Thanks so much, Daryl. Philippe, I think everybody can hear you now.
Terrific. Well, hello, everybody. I'm so sorry I can't join you face to face here on the actual hangout, but I did want to call in because I'm so excited about this. Thank you, Daryl, for hosting it here. Enjoyed working so much with Daryl, and this is such a critical issue. Water abundance or scarcity, as the issue increasingly is in the world today, and being able to explore that issue here in LA really taught us a lot about how these systems work. And I know that you all enjoy the expedition and everything that we put together, because this is such a critical issue, not just in Los Angeles and Southern California, but all over the world. And it's going to continue to grow in intensity and grow in importance. And we really wanted to tackle this issue in this expedition because, as always, we believe in the power of young people to change the world and in the power of all of you. And so we're excited to kick it off with kind of an exploration.
All right. Thanks, Philippe. We appreciate you jumping in, and we always love it when you can help us get rolling and get started. And with that, Daryl.
Well, I'm thrilled, always, Stacey, and thank you, everybody. And we look forward to working with you over the following year. This is just the very beginning, and it's really, really exciting. So thank you again, and thank you, Daryl. And I'll pass it back over to everybody over there.
Thanks, Philippe. Safe travels.
Thank you, Philippe.
Thanks.
Oh, and thank you, Philippe, for your leadership and vision in making curricula such as Watered by Design available to all students and teachers nationally and internationally. Back here at the West Basin Municipal Water District Water Quality Lab, again, in the afternoon of a typical day in my life at work, you could be talking to the chemists who are busy conducting their experiments, measuring the water qualities of the different waters we produce here, and finding out the testing procedures for example, all these bottles that are just lined up for a barge of tests that will be conducted this week to ensure that we're making high quality recycled waters. Another typical day, maybe later on the week, could be meeting with some exhibit designers, because I'm responsible for all the interpretive exhibits here at the Water Recycling Visitor Center. So this is right up your line, Arroyo Seco Museum Magnet School. Our Visitor Center has lots of different exhibits that describe how important water is, what we can do to take care of that water supply, and all the different ways that West Basin is trying to ensure a reliable water supply today and in the future. One of the things that I've been able to complete is a video game online. You can play it at westbasin.org and learn about how you can be good stewards by conserving water in the home, inside the home, and outside. So we developed these Water Star monsters, as well as our hero, the Water Star, who saves 20 gallons of water per day. So video games, you like to design video games? You could work for a water district and encourage people to take care of that water supply. In the afternoon of another day, I may conduct a presentation to a group of churchgoers who want to learn more about their water supply and who West Basin is. as far as the 17 cities that we provide water to here in the coastal region of Los Angeles County. And the last thing I may do at the end of the week is I may go ahead and touch base with some of the operators here at our water recycling facility to find out how the construction is going on outside. We're going through major renovations right now, and my tour route is constantly changing. And so I can stop in on our control room here at our water recycling facility and talk to our operators to determine what's a safe route to go, how water production is coming along, and make sure that our guests are safe when they go ahead and learn more about our water treatment process outdoor on our tour. With that in mind, it's a typical day for myself and for Diego. I'm wondering if any of you have any questions for me as a professional within the water industry.
Mrs. Griffin, does anyone in your class have any questions about Daryl and his typical day? Don't be shy, guys. All right, looks like we don't have any questions yet, Daryl, so if you want to keep going, we'll keep going.
Sure. Now, one of the challenging things about providing a drinking water supply to our area here in Southern California is our location. Let's go ahead and show them this map. Here you go. This is our map of our state, the third largest in the country, wonderful state of California. It was a great wet year. It rained and snowed a lot. And in this aerial photograph, you can see that our state of California is mostly green, the central and northern California region. That's where our mountains are, the Sierra mountain range, as well as the Klamath and Trinity Alps and mountain ranges up north. In a typical wet year, it rains and snows a whole lot up in that region. However, here in our state of California, most of the people, over half of our state's population, has decided to live in Southern California. And where we live right here, and Arroyo Seco Municipal Magnet School is located like right in this region here. And I'm located right over here, closer to the bay. We live in Southern California where it's hotter and drier. We have a Mediterranean climate here where it's long, hot, dry summers, very short, mild winters. With the population concentrated down in Southern California, we don't have a really reliable source of water. Historically, it's always been groundwater. We're fortunate here in our service area because we do have that we tap into, Coast Basin aquifer. And historically, the people here in the Los Angeles area were tapping into that water supply. But over time, after withdrawing too much water, that groundwater level began to sink. And when people were turning on their faucets, they were getting ocean water coming out through their pipes because as the groundwater was depleted, the ocean water from Santa Monica Bay was creeping further inland and contaminating where that groundwater supply once was. So that's why our agency was actually created, to help manage a drinking water supply here starting in 1947. And as a result, we had to supplement that groundwater supply. So we had to join another agency that helps transport water from the Colorado River over a couple hundred miles. And that's not enough water for us either. So they have to secure water from Northern California via the state of California that owns and operates an aqueduct. Now, here in the state of California, we have an aqueduct system. And Diego, if you want to zoom in on this, students can see what an aqueduct is. It's a large concrete channel. This black looks like pavement. It looks like a freeway, but this is actually millions of gallons of water that are transported from the origin of the water to where the water is needed by thirsty farms and thirsty people in cities. And so if we come back over here, Diego, to our state map, I'll go ahead and push the button to light up this map and tell you how far that water is coming from outside of the Southern California region. So the California Aqueduct is bringing water over 400 miles from Northern California, the Sacramento and San Joaquin Delta, to supply Southern California with water. Los Angeles Aqueduct is stretching from the Sierra mountain range and bringing water to the city of Los Angeles. We don't get any of that water here in our service area, unfortunately. But we do get Colorado River water via that aqueduct that transports water over 200 miles to the Southern California area. Once that water is treated at drinking water treatment facilities, smaller pipes bring that water directly to our homes, our schools, our businesses. And then we still have that original source of groundwater, the aquifer, within our service area. Get ready for it. Da 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 da. Boom. This is our complicated water supply system here in the state of California. When the astronauts on the International Space Station are up there looking down upon the planet, and Asia rotates upon its axis into the sunlight, they can see the Great Wall of China. And then when California turns upon its axis and the astronauts look down on the California, they can see California's aqueduct systems. So those are the only two human-made structures that the astronauts can see viewing down at our planet. Pretty impressive. And it's a very impressive and complicated system of transporting water hundreds of miles, very energy intensive. For example, at the beginning point of the Colorado River Aqueduct, this photo was taken. Here's the Colorado River, and there's a pump station in there, and each pump is the size of a small cabin. And each pump can pump out the water from an Olympic-sized swimming pool. And they have to be that powerful to pump water over the mountains so the water can flow by gravity to Southern California. So there's several lifts during its route. So when we use water here in California, we're also using lots of electricity, not only to transport water, but also to clean the water, heat the water, and then treat the water safely so it can be returned safely back into the environment. So there's lots of electricity and therefore money involved in getting water to your faucets for those of you tuning in from California. Okay? As a result of us depending on a little bit of groundwater, lots of Colorado water, Colorado River water in Northern California, that's what we're drinking here in our service area. It's a nice blend, a nice brew that we consume every day and we bathe with and cook with and flush our toilets with. Relying on an aqueduct system like this can be very risky too. Because here in California, we know our big natural disaster are earthquakes. And if the big one ever does hit, the aqueducts could rupture. And it could be up to 2 years before they're repaired. Other issues about depending on this transportation system, bringing water over hundreds of miles is there may not be water to be put into the system at the very beginning up here in Northern California or at the Colorado River, especially when there's a drought. We know that climate change is happening and there'll be less rain and snow in the upcoming years. We never know when that's going to happen. And the population pressures dictate how much water can be put into the aqueduct system also. People in Northern California want to retain their water too because they also need a water supply. There's lots of environmental regulations, policies put in place that influence when and how much water can be put into these systems. So West Basin Municipal Water District is similar to many other water agencies, maybe even in your own area, that are trying to create a locally controlled and sustainable water supply. And we're doing that in several ways. The first way is we offer lots of free water conservation programs to empower our residents and business owners in our area to conserve water and stretch out our existing water supply. I'll talk about that in a little bit. The next thing we're doing is we're providing recycled water. Clean water to be reused from sewer water. And the last thing we're doing is taking a closer look at the possibility of making drinking water from the ocean. Okay. Let's take a look at recycled water. Let's take a look at water conservation programs first, Diego. Let's give them an example of some of the things that we do in our service area. We provide lots of free programs and free devices for people to make a difference at home and where they work. We give away free rain barrels. This is a nice one that was decorated by a high school. It's connected to the rain gutter that drains water from people's roofs, comes down and it gets stored in the rain barrel, and then out the tap they can put a hose or their irrigation sprinkler system and they can use rainwater to irrigate their landscape. Only works when it rains, so that's like this. But you never know when it does rain, when it will rain. So it's a great way to always be prepared to stretch out a water supply by using rainwater. We give away free buckets, encouraging people to capture the water when they're waiting for their shower head or their bathtub faucet to heat up. They can use this water again outside, or they can use it to wash dishes. We give away high efficient shower heads. Again, all the devices for people to make a difference at home. We offer free landscaping classes where people can learn how to use drought-tolerant plants like succulents. They use a lot less water, but look really beautiful in landscaping outside. Because of the water that each person uses on a daily basis, half of that drinking water is actually used outside to water plants. A fun device that we give away for students that come on our tours is a Water Star water conservation kit. And so each student that comes on our tour receives if I can get out of the bag, a shower timer, a 5-minute shower timer that they can stick on their shower stall. Basically, we encourage them to take shorter showers. We give them pull it out, wait for it, a toilet tank bank. Basically, you fill it with water and set it in your toilet tank, so it fools your toilet into flushing with less water. And then this fun device, which we made up ourselves, I helped design this, a water waster fix-it ticket pad. It lists a whole bunch of water wasting behaviors, such as running water while brushing your teeth, taking long showers over 5 minutes, running water and washing dishes by hand. So we encourage the kids to go ahead, and if they see their dad brushing their teeth with their faucet on, they can check off that water wasting behavior on this citation and slap him with the ticket. So it's a great way for kids to get involved in being totally noxious at home and remind their family members to save water whenever they can. So again, a wide range of free water conservation programs to empower people with the knowledge and the tools to make a difference in stretching out our existing water supply. Okay? Water recycling, very fascinating process. Let's go over here, Diego. We're taking, of the 350 million gallons of water that get flushed down the toilet and drained out of the sinks and bathtubs of the city of Los Angeles, 350 million gallons of water ends up at the local wastewater treatment plant to be cleaned and get poured back out into the Pacific Ocean. Well, we're trying to reduce the amount of treated wastewater going out there, because when they're done with that water, first of all, you can imagine over 350 million gallons of sewer water arriving at their plant. It is the stinkiest, smelliest, chunkiest, brownest water you can imagine, coming from over 4 million people. But by the time they're done treating it, it looks like this. So do you want to come in and show them what this sample of treated wastewater looks like?
Looking pretty good.
Yeah. So this is the water that gets poured out into the ocean. And it meets all state and federal clean water regulations because it gets diluted with that ocean water out there. But this is basically polluted water that the dolphins and the whales have to live with. So we're trying to reduce the amount of water pollution going out there. So we take 40 million gallons of this water and we treat it further for reuse within our cities. So we add chemicals to the water, a ferric chloride, sort of like a heavy liquid iron. And then we add a synthetic polymer, looks like glue, acts like glue. And when we combine it into this water that we receive, we end up coagulating all those particles. And these particles are heavy because of the ferric chloride, or they're clumping together or coagulating because of the polymer, and they begin to sink to the bottom. I mean, remember, we're treating 40 million gallons of this water, so our filters are really large. And our filters are made out of coal. This is the same kind of materials that many drinking water treatment facilities use. Drinking water treatment facilities often use coal and sand and gravel to filter our water. Well, here at our water recycling facility, we can use coal. We pour this coagulated water through the top and out through the bottom, recycled water, which is perfect for irrigation purposes, watering plants. It's great for flushing toilets. It's great for dust control at construction sites. And that's primarily how it's used in our service area. Other water districts or water companies that make this recycled water can let their customers use it to help put out fires, buildings. They have ski resorts in the area. It can be turned into artificial snow. It can be put into decorative fountains. It can be used to water crops. There are lots of beneficial uses of recycled water, many different applications. And wherever this recycled water is made, maybe some of you in your own neighborhood have seen signs like this. Part of the city's conservation efforts, recycled water, or often reclaimed water is the term used, is used for irrigation purposes at this location. Do not drink. And that's because this is a lower quality recycled water. It has lots of minerals still in it. It's a little saltier from its first use in the city that it originated in. The coal isn't able to take out lots of the minerals that have been flushed down the toilets or down through the sinks. The purple sign is standard, as well as the purple pipes that this water flows through. So if any construction worker is out there fixing the road, rehabilitating a park, for example, doing improvements, they stumble across a pipe like this, they know not to connect a drinking water pipe, which is a white PVC pipe or a copper color pipe, onto a recycled water pipeline. It's really simple how we make this lower quality recycled water facility. It's really special because we're the only facility in the world that makes 5 different kinds of recycled water. Yeah, the lowest quality for irrigation, flushing toilets, and dust control purposes. But the other 4 types are purity, higher quality. It's a little bit more expensive to make. And since the coal can't take out all the extra minerals from the water through its first use in the city of LA, we have to use a different technology to make a higher quality water. And in fact, the highest quality water that we make exceeds drinking quality status. And the people coming on our tours here at the facility can actually taste sample our water. It's that pure. It's the same technology that we use in the exploration of ocean water desalination, which is the last topic I'd like to introduce to you all. Ocean water desalination.
Hey, Daryl.
Yes.
Before you get on to desalination, I would like to ask Mrs. Griffith's class if they have any questions about recycling water. Is that okay?
Sure.
All right. Mrs. Griffith, can you unmute yourself?
All right, hang on. Jacqueline?
Hi, everybody.
All right, I don't know if we lost audio.
Okay. Do any of your students have any questions on water conservation or the recycling of water before we move on to desalination?
No? Anybody? We lost audio for the last like 3 minutes, so we missed a little bit of it. But I have a question. So
Sure.
is that water that you guys are recycling, is that being pumped down into groundwater again, or is it just being used on the surface?
So the high quality water that we make through this next technology that I'm going to show you, it is purchased by the agency that manages the 2 groundwater basins in our area. And so, yes, it is being pumped back down into the ground. And several other water agencies are making reclaimed water that exceeds drinking quality status. It is being pumped into the ground in their areas also.
I think we're having some problems. Can you guys hear us?
All right, thank you. We can go ahead and move on to desalination.
Okay, great. So ocean water desalination uses the same technology for our higher purified recycled waters. One of the concerns about desalinating ocean water, well, let me back up a little bit. Desalinating the ocean water is very old technology. It's been going on for many centuries. In fact, the first Greek sailors in ancient times were taking water and letting the sun evaporate bowls of ocean water in order to get drinking water on their sailing vessels. Currently, there are over 1,000 ocean water desalinations across the country. Over 120 countries have desalination facilities making drinking water from the ocean. Here in the United States, we haven't really progressed with ocean water desalination because it tends to be a lot more energy intensive compared to importing water over hundreds of miles. The Middle East countries have been using ocean water desalinations for decades because they don't have, or they have very little fresh water. They have lots of ocean water, and so their technology has been historically more towards distillation, where they heat up ocean water, very similar to the Greek sailors, but instead of waiting for the sun to evaporate it, they use lots of oil, their petroleum, to heat up, create the heat to create vapor, and they condense that captured vapor as their drinking water. Well, membrane technology has now advanced ocean water desalination, and membrane technology is a lot more energy efficient, and the technology gets better every year. And so membrane technology is what we use here at our water recycling facility. And then we conducted a 5-year research project to explore the feasibility of ocean water desalination here within our service area, since the Pacific Ocean, again, is right in our backyard. Over 97% of the water on the planet is salty ocean water, and only 2% is fresh water. But some of that is locked up in glaciers, in ice, or in the vapor floating in the atmosphere. So with all that ocean water, West Basin Municipal Water District is trying to determine if we can conduct desalinated ocean water technology on an environmentally sustainable manner, as well as a cost-efficient manner, if it makes sense, compared to importing water over a great distance. The Pacific Ocean is always there. It's a potentially reliable source of drinking water, but we want to make sure we don't harm the marine environment as a result. The first step of desalinating ocean water, you need to bring in a large quantity of water into a potential plant. Lots of things are in that water, and as a visual, I have some of my stuffed dolls here to demonstrate that in the water, of course, are the fish, the whales, the dolphins that are swimming around out there in the ocean. But on the microscopic scale, there can be bacteria, there can be smaller viruses, and there's a whole bunch of salt in that ocean water. And the water molecules, these little guys, is what we want. We want the water left behind. And we want to be able to filter out these things and protect the animals. So over a large intake pipe during research project Diego, what we did is we put a screen. This is called a wedge wire screen. The pipe drawing in the water was down below. And the screen slots are very, very small. So when a fish is swimming by, like this, they can't fit into the holes and swim into the pipes. In addition to that, the intake flow of the water was brought in at a very slow rate, less than half a foot per second. That's like if your teacher told you to go ahead and run a mile, but you have 3 hours to do it. Oh, so you could practically crawl to complete that distance. So that's the first way that we determined successfully that we can protect the marine environment, by the strategic orientation of the screen, in contrast to the tidal flow and the water flow patterns, angled with the position of this screen, as well as the slot size and at the slow rate of the water being drawn in.
Hey,
So
Daryl.
to protect the animals.
We have a question
Yes.
from the Palmdale Aerospace Academy. And they want to know that even if you filter the water deeply, is there some bacteria that could still get through? And would the water have a salty taste, and why or why not?
So let me continue with the water treatment process, and the answer will be shown. So all the other things will pass through this screen. And the next state of the treatment process, the next stage, is ultrafiltration. Ultrafiltration membranes. And if we cut one in half, you would see that each ultrafiltration membrane has tiny white fibers inside, and they're hollow. How's that, Diego?
That's pretty good.
Okay, if we take one of these fibers up like this, imagine that it's a hollow straw. And if we blew up this hollow fiber, this hollow straw, really big, we'd see that the walls of each fiber have little holes in it. It's like porous, like a sponge. Those holes are 6,000 times thinner than a human hair. Let's go ahead and blow it up really big and do a demonstration. So this, the wall of the fiber, is now this. You can see the holes inside of the fiber, outside of the fiber. Process, our water molecule can happily pass through. Yay. The salts, we want to remove the salts, but unfortunately the salts still make it through the ultrafiltration process. Oops, fell down. Okay, so we'll remove them during the next stage. They still get through. But the bacteria, the broken seashells, the dirt, can't get through ultrafiltration. They get filtered out, they're removed. So that's the first phase of the water treatment process. We call that pre-treatment. We want to make sure that the heart of the water purification process doesn't get harmed. The purification process is reverse osmosis. The membranes here, no little white fibers. Instead, there's a center pipe, and the center pipe is wrapped by or covered with all these plastic sheets, very, very thin. Whereas ultrafiltration, the ultrafiltration membrane was cleaning the water on the microscopic level. Reverse osmosis is cleaning the water on the molecular level. And water molecules are one of the smallest molecules on our planet. So again, if we took one of these sheets from this membrane and blew it up really big, membrane pores would look like this, okay? We're talking about the molecular level. So where the salts now cannot pass through the center to that center pipe where the clean water is drained. Can't get through, the salts are left behind, but the water drops, think the water drops can make it through? Doesn't look like it either. But that's where we have to use lots of pressure to force them through, voila. And it can require up to 800 pounds per square inch of pressure. Now, I weigh 190 pounds, so that's like 4 of me standing on a square inch of your fingertip. That's a lot of pressure. And that's why here in the United States tends to be a little bit more expensive than transporting water great distances, because you still have to use lots of electricity to use the pumps, turn those motors to force the water molecules through these membranes. Now, these membranes are housed in pressure vessels like this. We actually took a whole unit and cut it in half. So you can actually see the center pipe where the fresh water comes out, and all the salts and any pharmaceuticals or pesticides don't fit through these layers, and they come out the other end as the waste byproduct. This is what a bank of reverse osmosis membranes would look like. Very similar to what our ultrafiltration membrane trains would look like. Very neat. Tends to be very noisy because of those motors. But again, since many ocean water desalination facilities exist, they often put these inside buildings to reduce the noise level so the neighbors aren't bothered by the noise of the pumps. So we end up with high quality drinking water that is also disinfected. But the other concern with desalinating the ocean water is for every gallon of drinking water that's produced, you end up with a gallon of highly concentrated brine. Now, this sample is a little bit old. It's been sitting in the sun for a little bit and it hasn't been disinfected. That's why it's a little brownish looking. But you can see, I don't know, Diego, can you actually see some of that salt that settled at the bottom? Yes or no? Not really.
Kind of hard to tell.
Well, some of the salt has settled out. So it's a real danger if we went ahead and just let this discharge back out into the ocean, because since it has a double concentration of salt water in it now, it's heavier than ocean water, and it could sink to the bottom and basically create a dead zone right around a discharge pipe. Animals and plants that can't live in a higher concentration of salt could perish. So what we determined through our research is that we can specially design our discharge pipes where the water or the brine that's coming out will mix up and dilute with the surrounding ocean water a lot faster. By law, any agency that's discharging brine like this would have to ensure that the brine is diluted to the surrounding ocean water salinity within 100 yards. That's the size of a football field. Through our research that we could do within 6 yards. So through our research, which is pretty exciting, and all the data that we collect is being compiled into a report right now, we help influence the new regulations for the California Ocean Plan of how agencies can go ahead and propose ocean water desalination facilities. These regulations are the most stringent in the entire world, taking into consideration the health and safety of the marine environment. So we're real happy as an agency to contribute to those regulations. And now our report is being compiled. It'll be issued for regulators and the general public to read and comment upon, and their feedback will inform our elected board officials who will make the decision of whether we'll advance further with a full-scale ocean water desalination facility here in the South Bay, and we'll continue to rely more strongly on imported water through the aqueduct system and groundwater, and expanding our water recycling efforts and continue with our water conservation programs. So that's it in a nutshell as far as water conservation, water recycling, and our research in ocean water desalination here in Southern California. There is a up and operating ocean water desalination facility down in San Diego in Carlsbad. They opened back in 2015 and are producing about 50 million gallons of ocean water daily.
Thank you so much, Daryl. I had a question also from the Palmdale Aerospace Academy, and they wanted to know, is it possible that the process of desalination could decrease the chance of drought in the future? And if so, how?
Definitely, it will definitely decrease the influence of a drought in any area, because again, a drought is caused by an extended dry period where there's a lack of available drinking water, and we, in our area, depend on drinking water from melted snowpack here in Southern California. So having the ability to tap into the ocean, which is a constant supply of water, and relying upon the technology to remove the salt, protect the animals, safely dispose of the brine, it all creates a new water supply that the local area closer to the beach has total control of. And if that local area has a new water supply, that means those areas further inland that don't have the ocean next to them, they can actually benefit from the drinking water that beach or that coastal area does not have to use anymore. Doubles the drinking water supply for everybody involved.
Thank you. We have a question from Miss Berkeley's bilingual second graders in New Jersey, and they want to know, what do you do with that excess material that's left over from the process?
So for the brine, again, this was a research effort for us. So the water that we're making, we're taking water, separating the salt from the drinking water, letting people taste sample the water when they came on tours. But then we recombine all the water back together again and put it back out into the ocean. For an existing or proposed ocean water desalination facility, the easiest thing and most cost-efficient method of disposing of the brine, the waste, would be putting it back out into the ocean, as I said, through discharge pipes. But again, we have to make sure that that extra salty brine is diluted and mixed very fast with the surrounding ocean water.
Thank you. Mrs. Griffith-Class, do you have any questions?
Yes, we have at least one. Christina?
Excellent. Come on up.
From the chemical, the chemicals that you put in the water, does it have any side effects in the water? Like anything that happens to the water?
Great question. And you're talking about the chemicals that we add to the sewer water that we're treating and trying to recycle water. Actually, just take a look back there, Diego. Because the chemicals that we add to the sewer water to create that coagulation, the polymer and the ferric chloride, again, we're settling out all these coagulated materials, waste materials, and what we end up doing is all that out of the water. The solids come out looking like this. This is a solid waste, the chemicals, plus lots of lime. We add this to increase the consistency into a sluggish texture. So we take all the chemicals that we add, and this gets hauled away to a soil remediation facility where they remove metals, they heat it up to fill up any pathogens, and this solid waste material can get reused and resold as construction fill or highway fill for those companies that don't have enough soil to build their buildings on top of or their highways on top of. And this can also be used as landfill cap to cover trash in our landfills. So we make recycled water. We're using solar panels to supplement our energy supplies here at our water site recycling facility, and we're recycling all the solid waste that are removed with the water too.
Great. Thank you so much. I would like to thank Daryl and Diego for hosting our virtual field trip today. Thank you guys so much. And let's see Diego one more time. There we go. And thank you, Mrs. Griffith's class, for joining us. We appreciate you being live with us on camera. Again, I want to encourage everyone to check out our newest expedition, Water by Design, which is now available on our website. It includes videos, lesson plans, design challenges, and other resources that will help your students learn more about these issues, such as aqueducts, aquaponics, and even desalinization, like we learned about today. So they will be available for free, and they are available for free now at www.earthecho.org. Thank you so much for joining us today, and we hope to see you all at a future live event. Thank you guys. Have a wonderful day.